Alright, so here we go. And we're back. Alright, so let's look at number 10. The issue is at infinity, so it is b goes to infinity. Antiderivative of cosine is sine, correct? Everybody got that? I evaluate it, but as b goes to infinity, what's the value of the sine of b? But somewhere between -1 and 1, but do we know what it is? So does this limit exist? No, there is. We do not know the area, so we say not that it does. It does not exist, because I want you to think about it. This graph goes on and on and on, and if you think about that area here, it's by the way, at that point, isn't that area 0? Would you agree? Yeah. At that point, the area is also what? 0. Here it's 0. Here it's negative. What's it right here? 0. What's it there? Positive. What's it here? 0 again. What's it there? Negative. But it keeps changing depending upon where we what? Are. So can we absolutely say the value? No. We could also say, because it does not reach a value, that it what? Virgins. Okay? All right, so number 12, did you get 1/60th? Because couldn't you apply this? Yeah. Isn't that just 1/10? Isn't this 1 what? 12th. So I get a common denominator. Do you remember how to find a common denominator? I'm open? Yeah. So that's 12 over 120 minus 10 over 120 gives me 2 over 120, which is 1 what? 60th. Because can't you break it up into two integrals if you want to? Yeah. That's the simplest way to do it. Don't try and combine them together. All right. How did we do on 12? Did we get 12? Yeah. Hope we got 12. What about 13? Did you just get that it equaled e to the x? I'm trying to hear you. Did you get e to the x? What about the next one? You get e to the 3k? Yeah, should be e to the 3k. Okay, let's flip it over. What did you get for 16? Did you get 1/10? Yeah. Okay, because antiderivative of this was x to the -2nd, bring the -2 out front, bless you, so I get 5/2. I still need to evaluate it between 5 and b. So the b is in the denominator, so is this, so it's 1 over b squared minus 1 over 25. If I multiply these, oh, that's 0. If I multiply these together, I get 1/10. Because a 5 cancels out of both of those, would you agree? Okay? All right. So we need to go back and do number, yes? Thank you. It's just E. I'm sorry. Thank you. Thank you, thank you, thank you. You call it E the first if you want to. Thank you. Thank you. Thank you for, you got my back again. You know, sometimes I like a massage, but we won't go there. Okay, number 9. Number 9, I wouldn't ask that of you. Let's look at number 9. Does that antiderivative look familiar? Yeah. Yes, it does. Hopefully it does. Okay. I want you to do a little thought process here. Where is our, I know I just wrote that. Is this ever undefined, that denominator? No, because it'll never equal what? Well, it never equals 0, right? So, yes, whenever you score 1 equal -4, at least not with a real number. Okay, so my issue is at where? Infinity. So I get 5 over 4 plus x squared dx. Okay, what is that antiderivative? Do you know? That is an arctangent. Okay, what is going to be out front on that arctangent? More than 5. 5 over 2. It's the square root of this. So it's 5/2 arctangent of x over what? 2. We still need to evaluate that between 0 and b. I should have made this 0 to b here. And I still need my limit symbol out front. And we got to put our thinking caps on here because we haven't done this yet. So this is going to be the limit as b goes to infinity of 5/2 arc tan of b over 2 minus 5/2 arc tan of 0. Okay, let's do this one first. Where is the tangent 0? Where is the slope 0?
Sine 0.
No. What angle is that? Where is the slope 0? At what angle? Where it's horizontal. So what angle is that? 0. The 90 is where it's what? Infinite, right? So where this says, where is the tangent equal to 0? So that's really at 5/2 times what number? 0. Okay. The second one is this. This is as b goes to infinity. That's saying where is the tangent infinite or where is the slope infinite? That's at what angle? When it's vertical, right? What angle is that? Pi over 2. That's at pi over 2. So I get 5/2 times what? Pi over 2. So what does that become? 5 pi over what? 4. Maybe that's a way I could approximate pi. Maybe, maybe not. Okay, so let's go down here and look. So we're going to do a very similar, actually, let's go do the one on the back because this will be a connection. Let's go do, we're skipping around, I get it. I want you to go do number 18. Is that also an arctan? Yes. Okay. So I actually want you to go do 18 and 17. Now I want you to look at your limits on 17. They go from 0 to where? They start at 0. So where is the problem? At 0. Okay. So let's go do 17 and 18, and then we're going to fill in the rest of the blanks here right after that. Okay, we have some oldies but goodies we're going to do today too.